These are the frequently asked questions for pre-calculus for section 4.7, day 2. And I'm going to start with number 25, although having gone over these in class today, I'm hoping that when you take a second look at these, they'll make more sense. The first thing we do is start with those innermost parentheses, and we ask ourselves, what is the cosine of pi over 4? Well, pi over 4 would be over here. That's, of course, 45 degrees. So we put our little special 45, 45, 90 triangle down there, and we think, well, what would the cosine be? Well, it would be adjacent over hypotenuse, which is 1 over the square root of 2. So now, what we're really doing is we're trying to find the inverse sine of 1 over the square root of 2. Now, 1 over the square root of 2, we know from past experience, is going to be the square root of 2 over 2 by rationalizing the denominator. But in order to see this, we really want to keep it like it is. So I start thinking, what angle would you have that would have an opposite side of 1 and a hypotenuse of the square root of 2? And we don't have to go anywhere because that's what this one has. If we use this as theta, then we have 1 as the opposite side and the square root of 2 as the hypotenuse. Well, this is this angle. And that angle was 45 degrees, but we need to put that in radians. So that will be pi over 4. Notice that both of those came out to be positive, and first quadrant is where everything is going to be positive. So the inverse sign there is going to be pi over 4. All right, number 26. Start with those innermost parentheses, and we have 7 pi over 4, and 7 pi over 4 would be 7/4 pi, or 1 3/4 pi. So what that does right away is it tells me that this is going to be pi over 4 for this angle theta inside there. Now, they wanted us to find the cosine of that. So, knowing that that, pardon me, is pi over 4, which is 45 degrees, I know that I have a 45, 45, 90, and it'll be 1, -1, and the square root of 2. And we're supposed to find the cosine. So cosine is adjacent over hypotenuse, and that's going to be 1 over the square root of 2. So both of those ended up being positive. Now we are supposed to find the inverse cosine of 1 over the square root of 2. And I notice that the cosine that we see here, this is positive. So I think about my PBR and where I should be putting cosine so that it will come out to be positive, and it has to be in quadrants 1 and 2. Quadrant 1 is where it's positive, so we would go here and say cosine is adjacent over hypotenuse. Pretty obviously that'll be a 1 over there. So this angle is a 45 degree angle, and as using it with radians, we'd say that's pi over 4. So that one involved figuring out where that PBR is for your angle. Number 27. For this one, the innermost parentheses are saying 2 inverse sine of 1/2. So we're going to start by realizing that we need to know where we're going to get a sine of 1/2. And since that 1/2 is positive, I'm going to go ahead and go in the first quadrant and think, all right, sine is opposite over hypotenuse. Well, we should recognize that. That comes from a 30, 60, 90 triangle. So that's a 30 degree angle right there. So for number 27, what they want is for us to find the sine of 1/2, inverse sine, I'm sorry, of 1/2, that's 30 degrees. But now we have a 2 in front. So they really want us to take 2 times 30 degrees, which means we're going to talk about 60 degrees. And what we're supposed to find is the cosine of 60 degrees. So we make another quick sketch and say, all right, they're really asking us for the cosine of 60 degrees, and the square root of 3 is across from 60 degrees. 1 is adjacent to it, and the hypotenuse is 2. And they want cosine, so cosine would be adjacent over hypotenuse, which is 1/2. Again, innermost parentheses first, then work your way out. Number 28 says the sine of the inverse tangent of -1. So let's start by figuring out that tangent being -1. And this is an inverse, so I want to think PBR, and that would be down here. And it would be a 45, 45, 90 that would make that happen. So this angle is going to be pi over 4, or 45 degrees. And now they want us to work forwards with that and figure out what the sine is. Well, sine also has the same PBR as tangent, these two quadrants right here. So if I realize that I have a pi over 4 down there for number 28, this angle would be negative pi over 4. Then what I have to do is make sure that my sines are matching up here, and they're all positive in first quadrant, but in fourth quadrant we have both a negative tangent and a negative sine. So they have the same negative or positive value as we go through that. So we can just go ahead and use the triangle that we have here to figure out that sine. So sine would be opposite over hypotenuse, which would be -1 over the square root of 2. And of course we would rationalize the denominator and make that negative square root of 2 over 2. So the PBR is the piece that you have to stop and think about. You know, if we're talking about sine and tangent, they have the same PBR. But if we're talking about cosine, that one uses quadrants 1 and 2. All right, that was 28. Number 29. For 29, they want to know the cosine of pi over 3. Well, pi over 3 is 60 degrees, and so we're going to go ahead and put our square root of 3 opposite the 60-degree angle, and 1 and 2 in the other two positions. So start with the cosine of pi over 3, that's adjacent over hypotenuse, and that would give you 1/2. Now they want to know what is the inverse sine of 1/2, because that's what arcsine is. So what we have to do is figure out our PBR and then work from there. So we'd still be in first quadrant. Sine is positive there. We could stay right where we are. And we want to find sine. But sine this time needs to be opposite of 1 and adjacent of, or I'm sorry, hypotenuse of 2. So I'm going to redraw this. I'm going to have to make another coordinate plane. That was the part I was wondering whether I'd have to do or not. So opposite of 1, hypotenuse of 2. This would be the square root of 3. The short side would be opposite the 30-degree angle, which is actually pi over 6. So that would be our answer for number 29. Number 30. 30 starts with, in the parentheses, tangent of pi over 4. And that, of course, is our 45-degree angle. And it looks like so. So with 30, the tangent of pi over 4 will be opposite over adjacent, and that will be a 1. So they're really asking us for the inverse cosine of 1. So we think, okay, cosine. Cosine has its PBR up there. So with this one also, we could just keep our drawing exactly where it is and say, okay, where is cosine going to end up being 1? And that is a quadrantal angle. 1, 0. And that is at 0 degrees, 0 radians, so it is at 0. So it does still fit in that PBR range that we needed. Number 32. (32) starts asking us about the cosine of pi. So come back here. Cosine is always the x-coordinate for the quadrantals. This is -1, 0. So they're really asking us about the inverse tangent for -1. So I start thinking, inverse tangent being negative, well, tangent's PBR is right here. So it would have to be in this quadrant. And to get a -1, we'd have to use our 45, 45, 90. So opposite over adjacent would make that happen. And so for number 32, as we work backwards to figure out this angle, this is a 45-degree angle, and it is going clockwise, so it will be negative pi over 4. Negative pi over 4. Innermost parentheses out. 34, analyze each function for domain, range, continuity, increasing or decreasing behavior, symmetry, boundedness, extrema, asymptotes, and end behavior. The first thing you want to do for number 34 is go back and get a sketch again of what cosine, inverse cosine looks like. A quick sketch should help everybody out on this one. So you go back and you take a peek at what we had for inverse cosine, and you will see that this is the information that we graphed by switching the domain and the range to get the inverse there. So our domain, our new x values are from negative 1 to 1. Our range, those are from 0 to pi. Those are our y values. And we see that this is continuous over its domain, but it's definitely decreasing. It is going down as you read the graph from left to right. Now, symmetry. Yes, it is symmetric. It's not, even or odd as we do that, but it is symmetric about the point. Zero pi over 2. So it does have symmetry. It is bounded. We cut it off on purpose, if you remember right. We were trying to find that PVR to use that would cover everything that we needed when we did our inverses. And it does have an absolute maximum of pi. And it does have an absolute minimum of 0. That again is the y value that we're looking for there. It doesn't have any asymptotes. And its end behavior does not exist. End behavior does not exist. So this is just going back and trying to remember all the characteristics of a graph that we talked about earlier this year, not losing any of that information. Number 37, this one says use transformations to describe how the graph of the function is related to the basic inverse trigonometric graph and state the domain and range. So with 37, you'll notice the 2 is with the x. And it's a 2, but with the x we always have to think opposite. So this is a horizontal shrink factor of 1/2. I'm going to shrink it by 1/2. So we want to think about what that's going to do to the domain and range in number 37. You might want to make a quick little sketch of what the graph looks like for inverse sine. Remember that one was quadrant 1 and 2, so negative pi over 2 to pi over 2, negative 1 and 1, switched positions, and the graph looks like so. So now, the domain. Well, the domain is the x values, and the x values we said were going to be shrunk by 1/2. So normally they'd be negative 1 to 1, but if we multiply those by 1/2, then it's going to shrink it to negative 1/2 and 1/2. Does absolutely nothing to the range. We're still going to have a negative pi over 2 and a positive pi over 2. Nothing has been affected there. 38 has a couple of numbers in it that are going to mess with us a little bit. So let's look at 38. 38 is inverse cosine. So like so. And what we have here is a 2 with the x. And that is going to, again, be the opposite of what we would normally think of with the x. So a horizontal shrink or compression factor of 1/2. But the 3 out in front, that is a vertical stretch factor of 3. So now we want to see what will that do to the domain and range. Well, the domain is going to be shrunk by 1/2. So we're usually going from -1 to 1, multiply that by 1/2, and it will be -1/2 to 1/2. And the range would normally go from 0 to pi, but if we multiply those two by 3, it will go from 0 to 3 pi. Next one on your list would be 43. So 43 says we are supposed to solve this. 2 sine of x equals 1. To do that, we'd go ahead and divide both sides by 2, and we'd have the sine of x equals 1/2. That means they want us to figure out any angles that would have the sine of a positive 1/2. So, in first quadrant, opposite over hypotenuse, we should recognize as a 30-degree angle. So that's going to be pi over 6. But then we have to think, okay, well, where else would sine be positive? Because this quadrant is positive, 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 negative, 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 positive, negative, positive, negative. Oh, over here it would also be. And we've got 30, 1, 2, and square root of 3. This is pi over 6 for this little chunk right here, but we want to know the name of it, which would mean from the initial side over, what would that be? And that would be 5 pi over 6. So we've got a couple of different answers here. We've got pi over 6, and then we have 5 pi over 6. And notice they did not use the inverse notation. If they don't use the inverse notation, then we have to tell them all of these. We don't use the PVR. And we start thinking, well, every time you go 2 pi around, you're going to land in another one that'll have a sine of 1/2. So we had better put plus 2 pi n on both of these, because it's those multiples of 2 pi that would bring our coterminal angles right back to where they are, where n is an element of the integers, and that will take care of all of them. So the big change in 43 is the notation. If they don't use inverse, we don't use the PVR. That is the big change. 44, tangent of x equals -1. And I'm starting to think about that 45, 45, 90 triangle, but I can't do this in first quadrant because everything's positive there. Could be in second quadrant. And it could be in fourth quadrant. So I need to figure out the names for those angles in radians. And this one, my 45-degree angle would be right here. But again, I want to think that's pi over 4, but starting from the initial side. So that would be 3 pi over 4. And down in this quadrant, we'd have a 1 and a -1 for this angle theta, which again would be pi over 4 in a 45, 45, 90 triangle. But again, initial side is here, go all the way around, so that will be 7 pi over 4. And I think, all right, so every time we go the 2 pi n around, is this going to hit? It will, but a little easier even to say, you know what? If I just rotate this one around, then I have that 7 pi over 8. So instead of using 2 pi, we could use 1 pi n, where n is a set of all integers. So their little sneak on these is that they don't use that inverse notation. And if that inverse notation isn't there, then we have to find them all. We are not limited to the PVR. So that is the piece that we have to pay attention to in these few problems. So 46 says we need the inverse sine of the sine of pi over 10. So pi over 10, you look at that and you say, how on earth are we supposed to know? That's not a special right triangle. Well, then you need to look at it and say, wait a minute, that's in first quadrant. So sine and sine inverse are in their PVR. This is going to work. So they will be inverses of each other, and the answer will be pi over 10. And because this problem uses the inverse notation, we want to take a look and say, okay, do we need to have all of them, or can we just stop at pi over 10? Well, every 2 pi around, this is going to happen. You know, we're going to end up with a multiple of 2 pi that gives us that pi over 10. So because these are both sine and sine inverse, we actually can go all the way around with this one. And they just ended up being perfect inverses of each other as we look at that one. And that just might be it. That is it.